Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about the idea of a significance test. All right, a significance test is a formal procedure for using observed data to decide between two competing claims, called hypotheses. The claims are usually statements about a parameter, like the population proportion, p, or the population mean, mu. So our hypotheses, we either have a null or an alternative hypothesis. So the null hypothesis is the claim that we weigh evidence against in a significance test. The alternative hypothesis is the claim that we are trying to find evidence for in a significance test. A one-sided alternative hypothesis. So if it states that the parameter is greater than the null hypothesis, or if it states that the parameter is less than the null hypothesis, then you're going to do a one-sided test, and your alternative would be one-sided, so it would either be a less than or a greater than test. A two-sided alternative test, if it states that the parameter is different from the null hypothesis, it could be either greater or less than, then it would be a not equal to test. All right, an example stating hypotheses. For each of the following settings, state the appropriate hypotheses for performing a significance test. Be sure to define the parameter of interest. Rob once read that 1/4 of all people have played/danced in the rain at some point in their lives. His friend Justin thinks that Rob's value is too high. To be true for high school, to settle the dispute, they ask a simple random sample of students in their school to find that 80 of the students surveyed, out of 80 of the students surveyed, 12 have played/danced in the rain. So my null hypothesis would be that P, the population proportion, is equal to 25%, so 0.25. The alternative is that it's less because Justin thinks that value is too high, so he thinks it's less than 0.25. And P, the parameter of interest, is the proportion of all students at the boys' high school who have played/danced in the rain. All right, part B. Raina lives in Austin, Texas. Historical records indicate that the average amount of precipitation in Austin in the month of May is 4.37 inches. Raina thinks the average May rainfall in her neighborhood is greater than 4.37 inches. Raina randomly selects 15 households in her neighborhood and gets permission from the homeowner and sets up rain gauges at each household. By the end of the month, the 15 gauges showed an average rainfall of 4.42 inches. So my null hypothesis would be that mu, the population mean, the average, is equal to 4.37. That's the claim that came from the records. The alternative, she believes it's more, so it's a greater than test, that mu is greater than 4.37, and we have to define mu. So mu is the true mean rainfall for Raina's neighborhood during the month of May. All right, the p-value is the probability, assuming the null hypothesis is true, of getting evidence for the alternative hypothesis as strong or stronger than the observed evidence by chance alone. Making conclusions in a significance test. If the p-value is small, then we reject the null hypothesis and conclude there is convincing evidence, and we would put that all in context. If the p-value is not small, then we fail to reject the null hypothesis, and we conclude that there is not convincing evidence of the alternative. All right, an example on interpreting a p-value. We learned that Rob and Justin had a disagreement about whether 1/4 of all students at their school had played/danced in the rain. The correct hypothesis for this test is a null hypothesis p equals 0.25 and alternative p is less than 0.25, where p is the true proportion of teens at the school who played and danced in the rain. When they surveyed a random sample of 80 students, 12 reported they had played or danced in the rain at least once, yielding a sample proportion, p hat, of 0.15. The appropriate significance test was performed, resulting in a p-value of 0.012. 0.01094. Interpret the p-value. So interpret the p-value is a little bit tricky. Assuming the true proportion of students at the school who have played or danced in the rain is 0.25. So assuming the null hypothesis is true, there is your p-value, 0.0194 probability of getting what we got, so a sample proportion of 0.15 or less by chance alone in a random sample of 80 students. So when you're interpreting the p-value, you're going to say, assuming the null hypothesis is true, there is a p-value probability of getting what you got or something more extreme purely by chance. All right, what conclusion could we make? So that p-value is pretty small. So we reject the null hypothesis because the p-value of 0.0194 is small. It's less than 0.05. That's kind of our cutoff, 5%. We have convincing evidence that the proportion of all students at their school who played or danced in the rain is less than 0.25. All right, go Seahawks.